All right, in this video, we're going to work through the following problem. It says write the vector parametric and symmetric equations of the line that passes through the point 1, 1, negative 1 that is perpendicular to both vectors d1, which is negative 1, negative 1, 2, and d2, which is negative 2, 1, 3. Okay, so there are those vectors. All right, and so remember the equation for the vector equation, right, for a line is going to be L of t equals the vector p plus t times the direction vector d. All right, and so the vector p is the vector that has initial point, the origin, 0, 0, 0, and points to, has a terminal point, 1, 1, minus 1. So that vector is 1, 1, minus 1. All right, and so next up we need the direction vector d, and they tell us that this vector that we're looking for is going to be perpendicular or orthogonal, right, to these two vectors right here. So what we need is a vector that is orthogonal to both d1 and d2, and of course we can get that by doing the cross product, and so that's what we're going to do. So we're going to take the cross product of d1 and d2. All right, so we're going to set up our cross product here. D1 is going to be negative 1, negative 1, 2, and that is negative 1, negative 1. And then D2 is negative 2, 1, 3. Negative 2, 1 there. Okay. All right. And so now we're ready to carry out the cross product. So first we have I times negative 1 times 3. That is going to be negative 3I. Then we have J times 2 times negative 2. That's going to be minus 4J. Then we have K times negative 1 times negative 1. That is going to be negative 1K. Like so. Then we will go back the other way. We have K times negative 1 times negative 2. So that's going to be 2K. Then we have I times 2 times 1. That's 2I. Then we have J times negative 1 times 3. That's minus 3J. Like so. Okay, and so what we're going to do then is to take these ones on the right and subtract off the ones on the left. So minus 3I, minus 4J, minus K, minus, and then putting these in the standard order, that would be 2I, minus 3J, and plus 2K. All right, and then go ahead and carry out those operations. Negative 3I minus 2I is going to be minus 5I. Minus 4J minus negative 3J is going to be minus 1J. And then minus 1K minus negative minus 2K is going to be minus 3K. And so our vector is going to be negative 5, negative 1, negative 3. That's our cross product. All right, and so that's the vector that is going to go here for the direction vector. All right, and so there is the vector equation for the line. And we can get the parametric equations by just go ahead and simplifying this out, carrying out these vector operations, scalar multiplying this t in, and then adding that vector to this first vector here. So that is going to give us 1 minus 5t for the first component, and 1 minus t for the second component, and then negative 1 minus 3t for the third component, like so. And then to write the parametric equations, it's just x equals the first coordinate, y equals the second one, and z equals the third component there. And then to just solve for t, right, to get the symmetric equations. So solving for t here, I get x minus 1 over negative 5 equals y minus 1 over negative 1. And then z, oops, I forgot a negative there, sorry. When I wrote it down from here to here, I forgot that negative. So that would be z plus 1 over negative 3 there. All right, and so that's the symmetric equations. All right, let's take a look at the geometry of it here. I've got this line. And let's see here. All right, so looking at my answers here, I have 1 minus 5t, and you can see on here I have 1 plus 5t. Here I have 1 minus t, whereas here I have 1 plus t, right? And here I have minus 1 minus 3t as well here. So what that means is that in this answer, right, I took the answer I did here, I had the direction vector pointing in the opposite direction. The direction vector for this line is 5, 1, 3. And you can see for this one we got negative 5, negative 1, 3. That's the one pointing in the opposite direction. Okay, so that's why the answer looks different. You can use the vector going the other way as well. And just to show you that, I can just change it, and you can see, actually I'll just add a new one in there, and you'll see that I get the same line, just to demonstrate that to you. So if I do 1 minus 5t, 1 minus t, and minus 1 minus 3t, that's from, let's just do negative 10 to 10. You can see, right, I get the same line there. Let's restrict it to a primary color and do the same thing here. So you can see I get exactly the same line. If I turn one of them off, you see it's right there. And so, so you know, sometimes you might get an answer that's a little bit off, if not off, but uses the direction vector in the opposite direction. That's perfectly okay. And you could get one where the point's different. There's infinitely many points on the line. So just like in two-dimensional situation, there are infinitely many vectors that are equations of a line that look different. Okay. But you know, here the direction vectors do have to be parallel to each other if you have a different version. Okay. And then you can see those lines are looking parallel. If we want to do the cross product, right, the cross product that I got was -5, -1, -3, I believe it was. Let's color that orange. So there's the cross product. You can see that is going to be orthogonal, right, to both of these vectors, the red one and the green one. And if I draw it with the point P, right, as the initial point, you can see that it is going to point right in the direction of that line there. Okay. All right, and so that is it on that problem.